The ratio of lengths of smooth and rough part of an inclined plane is 1 is to 2. The particle starts moving from top and again comes to rest at the bottom point. Then the coefficient of friction of a rough surface is. For this question, we are having these 4 options and only one option is correct. The corresponding picture is here saying that on this inclined plane, we are having 3 parts in which one part is a smooth of length x, okay, of length x, and the remaining 2 parts are rough. So this is of total length 2x. Okay, so the total length is 2x. This length, rough surface. Now we have to find the coefficient of friction of this rough surface. You better to know first the angle of inclination is theta for this plane. And now to solve this question, I simply consider this into 2 parts, right? In the first part, I only consider for a smooth surface, for smooth surface. What happens for this smooth surface now? See, if this is the smooth surface and we are having the particle right here, which is at the topmost point of the given picture, which is this one, okay, here. So where the initial velocity Vo is 0. And when it reaches this point, that is this point, right, on the actual picture, this point, at this point the speed is v. How much is this length? This length is x. If this is the situation, the acceleration of the particle along the plane downward will be g sine theta. Okay, this is the component of the acceleration due to gravity along this plane, inclined plane. Right. So now I better to use one equation, that is v square is equals Vo square plus 2ax in motion. Okay. So now v is nothing but this one, which is the final speed. So that is v square, which is equals this is the initial speed, which is 0 and plus 2 into the acceleration is g sine theta, g sine theta into x. Right. When I write it one more time, it is v square is equals to gx sine theta. This is the speed by the time when it reaches this part, this point. Okay. So now I consider the inclined plane for the rough surface. Okay. So now for rough surface, for rough surface. For rough surface, when I consider this like this, this is the rough surface. In this situation, the initial speed of the particle at this point is Vo, which will be the final velocity of the particle on the smooth surface. That means V square will be is equals to gx sine theta. Let it be as it is. Okay, so here the initial speed is Vo and also square is 2gx sine theta as we got here. Okay, so it is said by the time when the particle reaches this point, at the bottommost point, the speed is 0. It should be in rest, right? So it will come to rest. So this distance is 2x. Okay, now you should be careful because there are two kinds of acceleration now. So one is as usual the downward acceleration due to the gravity, that is g sine theta, and another one is due to the friction that is acting upward this direction, along this direction. This will be mu g cos theta. Okay, so since the body comes to rest finally, so since the body comes to rest, right, comes to rest finally, u, that is mu g cos theta must be more than g sine theta, right? So upward acceleration is more than downward acceleration. Therefore, net acceleration will be is equals minus. Why it is minus? With respect to the motion of the particle, the net acceleration will be upward. So that is a minus. It is a mu g cos theta minus g sine theta. This is the net acceleration, right? So it is mu g cos theta minus g sine theta. So further, what I can do is, again I am using the same equation, that is v square is equals vo square plus 2ax. The same equation I am using. So in this equation, when I make substitution, the final speed of the particle is 0. So that is equals, what is vo square? Vo square itself is this much. So be careful, don't make it square again, because we are already written vo square. So it is 2gx sine theta, right? This is since a is negative, here I can put negative 2 in the bracket. It is mu g cos theta minus g sine theta into the displacement is 2x. The length of the rough surface is 2x, right? So further, what I can write here is this is simply, since one of the term is negative, so these things will go on this side, and I can take out g as common inside. So it will be 4, right, g x, and inside bracket I can write it is mu cos theta minus sine theta, which is equals 2gx sine theta. Further, what I can do, I can simply cancel 2g and 2g, so it will be 2, and x and x also get cancelled. That means 2 times mu cos theta minus sine theta is equals simply sine theta. So now I bring this 2 to the denominator and RHS. So it is mu cos theta minus sine theta is equals sine theta divided by 2. So now bring this sine theta on this side. This will be mu cos theta is equals, so sine theta by 2 plus sine theta. Otherwise, what I can write? It will be mu cos theta is equals 3 by 2 sine theta. Further, for mu, this is a 3 by 2 tan theta, right? 3 divided by 2 tan theta. This is coefficient of friction in our equation. So in all the upper steps, mu stands for coefficient of friction of this inclined plane, right? So that means 3 by 2 tan theta is our answer. 3 by 2 tan theta is here, right? So this is our answer.